See the screen.
No, sir.
You can see the screen right now.
Yes, sir.
Okay. Okay. So, so today I want to discuss about the design, that is CAD as well as CAM. Okay. So before this, I think I told you in the previous class, AI, that is artificial intelligence, is very, very important right now. So artificial intelligence tools will be used in your mechanical industries also. As usual, I told you about uh, Python as well as your machine learning. Okay, artificial intelligence, deep and then deep learning. So all these things are very, very important right now. Okay, so kindly try to learn at least any one language. Okay, with respect to the Python, or you can go for the learning of machine learning. Okay, so machine learning as well as the Python, okay, is very, very important right now for mechanical engineers. So there are a lot of vacancies are there, regarding to the Python as well as machine learning, okay, for your mechanical engineering. I'm telling you for our branch, that is for mechanical branch. Okay, so if you go for any company, okay, so they will use like that is for data storage, okay, for storing the data. What is the meaning of data storage? Is nothing but, okay, storing the data from last 10 years. So if you want to store the data regarding to the production, that is production of the products from last 10 years, okay, they'll use the software like Apache Hadoop as well as Apache Spark. So these are the two softwares, okay, so that is exist for storing the data. So you can learn these two also. Okay, so that you can, so the company will be having, like if you go for like 30 50 years 50 years old companies, so there will be a lot of data will be available. So you can store those data by using this Apache Hadoop or Apache Spark. Okay, that's called as big data analysis. I think everyone has heard about big data analysis, right, students?
Yes, sir.
Hello. So see, this big data analysis is nothing but the volume of data. Okay, right now it has been increased. So if you take a new company, okay, that is 2020 or 2019, which is exist, okay, the data will be small, so that they can use the Excel sheet, okay, normal Excel sheet to store the data. But when you come to the old companies like Infosys, Wipro, okay, so these are established more than almost 20 years back, 20 to 25 years, more than 25 years. So to store all those data, okay, so we want some softwares. Okay, that is called as that is called as data storing. Not only regarding to your production. Okay, you should store the data regarding to the design. Okay, regarding to the manufacturing, regarding to every field. Okay, how much has been sold for a month, for a day. So all those data we should store in a software. So this is called as data. So this is called as data storing. So this will be done by a software called Apache Hadoop or Apache Spark. So by these two softwares, we can store the data. Okay. So if you come for your then okay, after data storage, okay, then data collection. So data collection is nothing but in the software. So okay, we will try to update everything for a month. So how much sales has been happened, how much production has been happened. So how the design has been changed from one farm to other farm. So all these data, okay, we will store, okay, in the software, that's Apache Hadoop or Apache Spark. Okay, by using the software, we will store everything. So I'm telling you about AI, artificial intelligence tools. So what they will do in the company, mechanical company. So there are a lot of vacancies are there regarding to the mechanical industry. They want who knows to store the data. Okay, like Apache Hadoop or Apache Spark or Python. So Python is used for basically to write the programs. Okay. So next it will go for data cleaning and exploration. So data cleaning is nothing but after collecting the data, okay, and that's unwanted data we should remove. So for this unwanted data, okay, we should remove from the, what you can say, from the from the data collection. So this will be done by, I think, this can be done by I think NumPy. Okay, it's called as NumPy and Pandas. Okay, these are the two softwares that the mechanical companies they're using to clean the data. Okay, it will clean the data. That means the unwanted data it will remove. Okay, so you want NumPy also, NumPy and Pandas. So by using these softwares, we'll remove unnecessary data. After this, we should build a model. Okay, So build a model means, okay, you should build a model by using the Python programming. So next we'll use the Python programming to write the programs, okay, to build the model. After that, after writing the programs, execute the program, okay, by using machine learning. Machine learning, but machine learning is nothing but, okay, writing the equations. So we'll write the mathematical models, okay, in the Python programming, and we will get the results. After getting the results, I will collect the results. Okay, what you got in the Python. Okay, then we will try to implement. Then we will try to read the results, and and the results are okay. Then we will implement those things in the practical. What you can say, in the practical manufacturing plant. So this is nothing but a process, okay, which is going through now. Okay, if you take 2000, from 2019 2020, there are a lot of mechanical companies. They're asking their students, okay, who knows the basics of Python programming. Python, either Python programming, or you can go for Apache Hadoop or Apache Spark. Okay, and you can go for NumPy, Pandas. Okay, so this for data cleaning. Then you can go for Jupyter. That is Jupyter. So Jupyter is nothing but a similar, what you can say, library like Python. So Jupyter, in Jupyter, you will be having lot of, what you can say, lot of library. So in that you can use the Python also. You will be having Python, you will be having NumPy, you will be having Pandas. Okay, in the same Jupyter software, okay, you'll be having all the library. So you can use one by one. So use NumPy to clean the data. Okay, to store the data, so you can use the Apache Hadoop. And to write the programming, you can use the Python. I think everyone is getting right what I'm saying.
Yes, sir.
So everything you can do by using system only. So now the computers are very important in mechanical field also. So right now I told you lot of 3D images or 3D designs. Okay, you can do in Python also. So in Python you can what you can say, you can generate the 3D drawings easily than your SolidWorks. Okay, so only they're trying to implement. There lot of mechanical companies, they're trying to implement Python. Okay, in their company. Okay, if you go for NIL, if you go for Bosch. Okay, Bosch, they're giving the training for the employees Python. Okay, Python, machine learning, all these softwares. Okay, they're giving a training for the employees. Okay, so that the employees can learn the software and they can implement. Okay, they can write the programs. Okay, they can solve the problem very easily. Okay, for that you want what you can say, you want these softwares. Like if you go next, you can go for Matplotlib library. So this is Matlab library is nothing but for visualizing the data. So once you enter all those data, okay, to get in the form of bar chart, or you can say different types of charts. Okay, so you want this matplot library. So this is a library used for getting the bar charts or whatever pie charts, whatever you want to chart, different different types of chart for data analysis, for data, what I can say, whatever you are collecting the data, okay, to get in the form of bar chart, okay, we should use this matplot library. Then it will come for deep learning. So in deep learning, I think you can search TensorFlow. Okay, you can write down now. You can type TensorFlow and try to learn this TensorFlow. So TensorFlow basically is used for what I can say, for analysis. Okay, so after collecting the data, so you should do the analysis, right? So for so right now, TensorFlow is a very important software. In the other countries, they're using the TensorFlow. In India, almost one or two companies they're using. So I think within next year, this TensorFlow will come into picture. So I'm also trying to see this TensorFlow. So you also see TensorFlow. It's a very important software. I think coming within one year, okay, TensorFlow may used by all the mechanical industry as well as the IT industry. So both the industries, they will be using this TensorFlow. But right now, one or two companies, they're using this TensorFlow. Okay, so lot of students, they don't know what are the different softwares they have and which one we should study. So that is very important to first analyze. So which software is important, which software I should study. So which are softwares, okay, those which are having demand in the industry. So all these things you should analyze first. So today I'm telling you all these things because you should know this AI. So without AI, okay, without AI right now, okay, without learning some software regarding to the artificial intelligence tools, okay, what I'm telling you now. Without these things, if you can enter into the industry by some software like CATIA, Pro E, or whatever it may be, analysis that like FEM and ANSYS or whatever it may be. But the next few years, next 2 to 3 years, you should also update these softwares. Okay, you can join by using the mechanical softwares, but we don't know within 2 to 3 years. Okay, all the softwares we need to be changed regarding to the Python programming, or we can go for Java. Okay, we can solve mechanical problems by Java also by Python, but Python is the number one software right now. But it can change. I don't know, within 3 4 months a new software may come into picture. Okay, so I'm telling you right now Python is the number one software. Okay, which will be used by all the departments. If you go for electronics, if you go for CS, if I go for mechanical, so all the problems, the complex problems, you can solve easily in Python. So a lot of companies they're offering for Python. Okay, they'll give a huge salary, but students don't know about the Python. Python for what you can say for mechanical problems. I think everyone is getting right.
Yes, sir.
So like this, if you go for Skykit Learn is there, okay, SQL Learn is there. So there are a lot of softwares are there, okay, to get the data, to analyze the data, to data clearing. You want some softwares, okay, to write the programs. You want Python. Then another like same similar to this another is there. I think that I forgot the name. PyCharm. I think PyCharm. So PyCharm also is similar to your Python. Okay, that PyCharm also we can write the programs. So there are a lot of softwares are there. Okay, to write the programs, to execute them. Okay, then machine learning. You want machine learning, deep learning. So everything is very important. Okay, right now. So um, uh, try to analyze and learn some softwares. Okay, regarding to the your mechanical. If you want to be in mechanical stream, so kindly try to learn Python for only for mechanical problems. Don't go for IT or CS. Okay, if you're interested in that, you can learn. But if you want to be in mechanical stream but throughout your career, kindly focus on only mechanical problems. Okay, only your mechanical stream problems. So then it will be easy for you when you enter into the industry. Python, which is just go to mechanical, then it will go. Then you can work in the mechanical stream itself. So any doubts in this? So it's called as data science. So data science, if you study for mechanical, it will be good. So you'll get lot of jobs. Okay, if you see, if you Google, if you go for Google and if you type Python jobs in mechanical industry, you can get lot of jobs available. Okay, then you have SQL. Okay, SQL software you have. So SQL is used for it's called a structural query language. Okay, this structural language query language is nothing but used for what you can say dealing with the data. Okay, from the data tables which should be used. So if see after collecting the data, you will go for I told you right Matplotlib library. From that we will do the bar charts, pie charts, so that we can get the results. Okay, about the data results. Then we will use this SQL system to analyze the data. Okay, whatever we collected the data to analyze. So what is happening from past 10 years? What is happening in our company? So how much is the sales? How much is the production? So how much we are how much product we are manufacturing more? Okay, than the demand. So everything we can analyze by plotting that Matplotlib. Okay, Matplot library. Matplotlib. Okay, Matplot library. Okay, in this you can see you can form the what you can say bar charts or pie charts. By that we will go for SQL. In SQL we can analyze. So what is happening in our company from past 12 years, 15 years, whatever it may be. Okay, so you should learn all these things. Okay, it's very important. Then PyCharm I told you. So these are lot of softwares you have. Okay, in the if you go for Google and if you type, okay, you get lot of this one these softwares. You should decide depending upon the which industry you are moving. So try to get the information and try to learn depending upon the whatever demand. Okay, you have in the industry. So if lot of companies if they're using the Python, then Python. Okay, if you want to become a data analyzer, then you should go for Apache Hadoop and Apache Spark. If you want to become a machine learner, then you should go for the TensorFlow scikit-learn, and sklearn. So these are very important, okay, to write the mathematical model equations, okay, for any particular problem. So all this, what I'm telling, okay, this is regarding to the what you can say right now. Okay, right now what the trend is going on. So in the mechanical industry also, I think everyone has understood, right?
Yes, sir.
Then if you go for other deep learning, if you go for TensorFlow, then PyTorch is there. Then Keras, some Keras library also is there. So these are main important for what you can say deep learning. Okay, so deep learning is nothing but clear understanding of the neural networks. Okay, neural networks, that is artificial neural network. You type artificial neural network in the Google, so you'll get. Okay, so input to output. So what are the inputs we should give, like equations? So what should be your output? So we can solve all those things in the deep learning. Okay, so you can see these things in your. You can get all the information in your Google. Kindly search to your mechanical industry. So basically, first important thing is you should learn that is NumPy and Pandas to clean the data. Okay. First, data collection is nothing but what I told you, like Apache Hadoop, Apache Spark. Then data cleaning, your NumPy and Pandas. Then writing the program Python. If you learn these three right now, okay, it's enough to enter into the industry. So these things will come under this whatever I told you, AI tools. Okay, AI tools is nothing but whatever I explained you now regarding from the data collection to the solving the problems. That is, I told you a lot of softwares: data collection, Apache Hadoop, Apache Spark, NumPy, Pandas, Python, PyCharm, then TensorFlow for deep learning. Okay, so these are the softwares. Okay, right now, so there's more trend. So if you learn these softwares, you can enter easily into the industry. So I think this is called as AI. Okay, that's artificial intelligence tools. So anyone has any doubt in this?
No, sir.
So these are the existing tools what you have. Okay, you can enter through CAE. You can enter into the industry, that is CAD. Okay, you can enter into the industry by this DFMA, design for manufacturing and assembly. Okay, then production tools, you have a lot of tools you have. Okay, you can learn easily. Okay, you can, if you want to become the component integrated manufacturing, you can learn some softwares out there. You can learn that, and you can enter into the industry. Okay, but basically you will get more package or more, what you can say, in your words, more money. Okay, regarding to the job you will get in AI, in machine learning and Python. So the maximum, what you can say, you can get within less time, within 2 to 3 years, you can get more money in AI rather than your design or analysis. Okay, so particularly your AI, if you enter into the industry with respect to AI, okay, without experience, within less than 2 to 3 years, you'll get more, what you can say, more salary. So for that purpose, I'm telling a lot of things regarding to this. Okay, so try to learn yourself. I think for Python for mechanical engineers, it is less. Okay, the teaching in outside, it is very less. So you can learn by yourself. Don't worry. You go for YouTube, search in the individual Google, or if you want, I will give some, what you can say, some links for you, so you can read by yourself and you can learn. Okay. So management tools also you have. So don't worry about the management tools. So try to learn. So management tools are SAP. Okay, SAP SAP. SAP also, it was in previous 10 years back, or 8 to 10 years and 10 years back. Okay, SAP was having a huge demand. Okay, so they were getting more than I think 10 lakh or 12 lakh within 1 year or 2 years experience. But right now, this app also has been come down. Okay, SAP is used for collecting the data. Okay, whatever the your the Adobe I told you, right. So those things, Apache Adobe and those things. Okay, that is called as data collection. This app also is used for data collecting. Okay, data collecting and storing in the company. Okay, so SAP was initially, like 10 years back, it was a huge demand was there. So for learning only, they were asking around 3 lakh rupees. Okay, for the course it was 3 lakh rupees. after finishing of the course, okay, you're getting a huge package. Okay, previous 10 years back, but right now SAP also they will use in the industry. But regarding to your AI tools, okay, this app also the salary will be less. I think everyone has understood, right?
Yes, sir.
So this simulation tool, whatever I explained you now, okay, in the previous slide, the same thing I have written here. You can read. You can read and you can analyze. The only thing here is FEA. Okay, right now FEA is also very important. That is finite element analysis. You can enter into the industry by FEA. Okay, for solving the complex problem. Okay, they're going for FEA itself. Okay, for steam turbine blades, example for steam turbine, wind turbine blades. Okay, so because Python, by using Python, so the what you can say, the employees don't know how to solve. So that is a problem. Okay, by using the Python for wind turbine blades or steam turbine blades, okay, it's very difficult to solve. Not difficult. Okay, the lot of employees they don't know how to solve the problems by using Python. So that is the reason still they're using FEA only. That is your Abacus or Nastron or ANSYS Workbench. So these are the softwares, okay, they'll be using for solving the problem. That is for complex problems. Okay, still they're not going for Python because they don't know how to solve. So that is the one thing. That is the main thing because from last 1 year only the Python came into picture for mechanical industry. So a lot of employees they don't know how to use the Python. So only there are a lot of vacancies are there in Python. Okay, I told you Python is used for writing the programming. Okay, we'll write the programs regarding to the prompt statement, and we will try to solve the problem. Similar to your FEA. Okay, but FEA, so for simple problems like mechanics of materials, then if you go for kinematics of machine or design, you read about machine design, right? Machine design one and machine design two. Machine design two. Your shaft problems, or if you go for any problems in the design one and design two. Okay, that is gates, spur gear, helical gates, and springs, right? Look, and then lubrications, all these things you said in the design one and design two, right, students? Hello.
Yes, sir.
So all these things we can do easily in Python. But when you come to complex problems, okay, the complex design, complex geometry, so then it will be difficult for solving the problem in Python. So if you want to enter into the industry for regarding to the Python, if you learn the basics, the basics means what? If you know to write the programming regarding to your mechanics of material problems, then kinematics of machine problems, and your DMU and DMU2 vibrations problems. So all these things, okay, if they give some prompt statement regarding to the simple one, okay, if you are able to write the program and if you execute, so that's enough to enter into the industry. Later on, they will give the training for you, okay, for solving the complex problems. Okay. Any doubt in this?
No doubt, sir.
Okay, good. So I think everyone has understood AI tools, right?
Yes, sir.
So be careful if you want to move on to the industry within next 2 years. You want to know the Python programming. All these things are very important. See, I'm stressing a lot. I'm stressing these things for you because you should understand what is the demand right now. So okay, simply if you move to the industry regarding to the CATIA or ProE, okay, or whatever it may be, so then it will be difficult for you, right? Once you enter into the industry, then it will be difficult for you to work, okay, without knowing the demand of the softwares in the industry. To work in the industry, it will be very difficult. So only I'm telling you number of times. Kindly look into this. Kindly look into this. So I think if I think 9 students are there, at least 3 to 4 students, if they enter into the industry with respect to AI, then it will be good. Okay. Or initially, you can enter into the industry by using your regular softwares like design or analysis, whatever it may be, or production. And later on, you should try to update yourself. Okay. Try to update yourself, and you should jump to the AI softwares. Okay. So for that sake, I'm telling you number of times. So anyway, within 2 months, okay, I think if you work in the industry, okay, you will get to know. So what are the different softwares you'll be having? So what are the different and the company, okay, what they will be saying, which softwares, okay, you should learn. So everything, okay, they'll be updating for you. So regarding to that, you can update yourself. Next, we'll go for this and all anyway over. So CAD systems in VPD. So what is VPD?
Sir, virtual product development, sir.
Good. So virtual product development, as usual, I told you, virtual product development is nothing but virtually we will be creating the 3D modeling. So like if you use CATIA or Pro E or whatever the softwares, AutoCAD, Unigraphics, all these softwares are used for converting your conceptual design to your conceptual design to the 3D modeling, right? So
Yes, sir.
So it's basically you can see CAD technology will be equal to design techniques. So design techniques is nothing but whatever you're writing the conceptual design. So if you have conceptual design with you, and if you have the computers, so that is systems. If you have system, then you can convert into 3D, right, by using some softwares like CATIA, Pro E, or whatever software you have. Okay, you install the softwares, and if you have the computers, okay, so you can easily convert your conceptual design to your 3D drawing. So that is called as virtual product development or product design. Okay, not development, design, virtual product design. So virtual product design is nothing but virtually we are making the 3D model, not practically. So directly we're not converting your conceptual design to the what you can say manufacturing of the product. So initially, if you go like 1900s or 1950s, 1960s, okay, the softwares were not there. I think softwares like design softwares was exist in 19 around 1995, 1995, 1990. Okay, but in India it was around 1995, 1996. Okay, the computers will exist in India around 1995. Okay, so basically the design like your software CATIA or whatever it may be, SolidWorks, it was introduced around in 1995, 1996 in the industry. So till that, okay, so there were no virtual product development. Only after conceptual design, if all the department heads, if they agree with respect to the CEO, directly it was going to manufacturing. I think everyone is getting right.
Yes, sir.
So only they will draw the 2D drawings with respect to hand sketch. Whatever whatever, okay, they were using the drafting, and they're converting all the conceptual design to the first. They will convert into the dimensions. Okay, then they were drawing the 3D view. That is by using the hand. Okay, by using the drafting. Okay, they were using drafting, and they were writing the drawings. Okay, that is previous. I think. So 1990, beyond 1990, they're using the drafting. So if you go for Google and if you type there, okay, the 3D drawings in 1980 or 1970, okay, you see, okay, so they so they were they were writing with respect to they were writing the sketches, they were drawing the 3D drawings with respect to the drafting. Okay, you can see. If you want, I will show you. So then you can understand easily. Um, I think it is not showing, but I think then I think I saw a photograph, but now I think 1970s they're not showing. Anyway, if I get, I will forward you. Okay, but anyway, if you search, okay, you will get those things, but you should see carefully. Anyway, I'm not getting those things. but they were using the drafting, okay, for for writing the for assembly drawings or 3D part, whatever it may be. They're using the assembly drawing. Sorry, they're using the drafting. Okay, so now those things are eliminated. Okay, you should know. First, we will create by using the software, right, students? First, we will use the softwares to draw the model. Okay. First, conceptual design. Then the conceptual design will be converted into your 3D model by using by using the softwares. Okay. Then, if all the employees as well as the stakeholders, your customers and CEO agrees, then it will go for the FEA team, that finite element analysis. They will solve the problem. Okay. If the results are okay, then it will go for implementation. That is manufacturing of the real part. So this is about the CAD system. Anyone has any doubts in this? Students, any doubt? Hello? Students, any doubts?
No doubt, sir.
Okay. If you see here in the second slide, okay, I'll make it big. You can see here, okay, you should have three components. One is design engineering. So design engineering is nothing but the software. Okay, if you have software and if you have the geometrical modeling, that is your geometry, your conceptual design. If you have the geometrical design, your 3D views, as well as the design engineering softwares and the graphics and computer graphics. So it's very important. You want to have the computer graphics like 2 GB or 4 GB, depending upon the complexity of the geometry. So if you have these three things, okay, easily you can make the 3D design. You can see the definition. It is defined as that is your computer aided design is defined as the application of computer and graphic software, okay, to aid the product design from the conceptualization to the documentation. To convert from your 2D drawings or conceptual design to the 3D drawings, you want geometrical modeling, design engineering, as well as the computer graphics. Then if you go for next slide, okay, need for CAD and CAM. What is CAM, students? Can anyone tell me? What is CAM? Computer aided
Sir,
manufacturing.
computer manufacturing, sir. It helps you like determine what machines and in what order it's required to manufacture a particular product.
Okay, good. So computer aided manufacturing is nothing but example what you did in your sim lab. So what did you use sim lab? You use the Siemens
CNC
software,
Fanuc OIT, sir, software.
Fanuc software. Why you use to see whether the programming is correct or not. So we will write the programming and we will see the result. So what's happening? Okay, in the software. So we will write the programming G codes and M codes. We'll use the G codes and M codes to write the program. Then we'll execute in the software and we will see whether whether the product, the results or the output of the product, okay, is similar to our drawings or not, right? So first we will write the drawings, the necessary output, like if you want threading, internal threading, outer, then external threading, internal boring, then the taper turning, or you can go for knurling. So all these operations we will write in a bar, sorry, in a circular bar. Okay, then we will write the programming according to that. Okay, we'll write the programs, then we'll execute in software first. Okay, that is called as computer aided manufacturing. First, we will see virtually. First we will see virtually in the softwares. Then, if it's correct, then if the results are correct, then we will go for implementing in the actual CNC machine, CNC turning machine or CNC lathe machine. I think everyone is understanding.
Yes, sir.
So this is the best example for CAM, computer aided manufacturing. That means first we will see in these softwares. First we'll implement in software. Okay, we'll write the M codes, G codes. We'll write the programming. Similar to that, Python also will do same thing. We want to write the programming. We should see the results. Depending upon the results, we should go for implementation. Same wise in CNC programming, we'll write the milling machine or turning machine, whatever it may be. We will write the programming. We'll execute the program in the software. Okay, if the result is correct, whatever we want. Okay, so if it is correct, then we will implement the same programming, whatever we written the CNC program, we will execute in the actual CNC. We will go to actual CNC machine. we will import all these programs, we will add there, and then we'll go for execute. Then you will get the required, what you can say, required shape of the workpiece or required shape of the product. So this is called as computer-aided manufacturing. Okay, you can see design. Okay. Design and manufacturing form the core of engineering. First, you want to design. First, always you should see. First, we should go for virtual product design. After that, we should implement it. So depending upon the usage of the CNC program, okay, we will convert into the product. Okay, well, this is virtually. I'm not telling the real manufacturing system. So real manufacturing system is different, and virtual manufacturing process is different. So first we should see in virtual if all the inputs is correct and whatever you want the required output, okay, it is correct. Then we will implement all those inputs into the real manufacturing system and we will get the output. I think everyone is getting.
Yes, sir.
So what is the advantage by using the virtual means? So initially, if you use virtual manufacturing system, so we can eliminate the we can eliminate the investment of the cost of for the raw materials, and we can see and we can what you can say, save the time to manufacture the real product, and we can see the whether the product can sustain or whether this product can sustain the what you can say, the load or not. So whatever it may be, first if you do, we can control all these things like money and raw materials. We can save the raw materials, we can save the time. So all these things comes under what you can say, virtual product manufacturing. So in this process we can save everything: money invested, then raw material will be wasted, then how much time, then time waste also we can control. So everything we can control initially itself. So if everything is okay in the virtual product development, then only we'll come to the real manufacturing production. Okay, so this is very, very important. So for that purpose you want your CAD and CAM. So CAD and CAM, because of to save the money, to save the raw materials, to save the time of the company, all these things, to save all these things, okay, we will first try to implement either the design, virtual product design, or virtual product manufacturing. We will see initially if everything is okay, then we will implement all these inputs into the real manufacturing plant. We will send all these inputs to the employees, so that employees will follow the inputs and they will manufacture the product according to the the product design engineer will send the input for them. They will follow those inputs and they finish the task. I think everyone has understood, right?
Yes, sir.
So whatever I told you, okay, I think it will be written in the form of words. You can see here, design and manufacturing forms the core of engineering. You know that, okay? So you want the design tools as well as manufacturing tools to analyze. Okay, if you go for casting also, so first we will see in virtual. So we'll pour the molten metal into the pattern or mold. That's virtually. I'm telling you virtually. So directly they will not pour the molten metal into the mold cavity. First, they will see virtually. Okay, they will pour and they will see wherever the stress concentration is more, or wherever they got more whites. Okay, they can see virtually, and then they can change the design of the pattern, or then they can change the temperature. Okay, the what you can say, the melting temperature, whatever it may be. Okay, they can change the whatever they need, and they can analyze. First, they will analyze if everything is okay, then they will go for implementation. I think everyone's understood. Wherever you go in the mechanical field, first they will see virtually. Now, I'm telling you now, if you go for MNCs, every MNC companies, they will see virtually first. If they're okay with virtual, then only they will go for implementation. So you should know virtual first. Virtual is very important. So real life is very easy. So once it is okay with virtual, 90% or 90 to 95%, okay, it will be what I can say, it will be okay in real manufacturing process. If you know virtual, you can sustain in the industry. I'm telling you a number of times. If you know virtual tools, okay, then you can sustain in the industry. So manufacturing is very easy. So only virtual virtual will be having more weightage than your real manufacturing process. Like manufacturing engineer will get less salary than your virtual what they will be doing. like FEA, Python, machine learning. So all this package will be very high. Okay, then to remain the competitive in global economy. Okay, that is to remain means competitive means to give better product, right? To give good product, or to give a better product, or to give a better product which will be better technology, which is to be stored in the product. So to remain in the competitive, okay, your company, then you should give a better product. For that, you need this software tools. Okay, new product will enhance features at competitive cost. I told you, right? Always you should try to update your product with respect to some technology. Okay, you should see the technology which has been exist today or tomorrow, what it maybe you will be try. You should be trying to update yourself and yourself as well as in the product. If you update the technology, new technology in the product, then your product will sell well in the market. Then short lead times on short product lives, and reduction product life cycle. So all these things, okay, it will be helpful if you use the virtual product development process or tools. Okay, then mass customization. There is customer specific changes to satisfy diverse requirements, high flexibility in the manufacturing system, then reduction in manufacturing cost and delivery time. So it's very important. I told you reduction in manufacturing cost. Okay, you can reduce the cost of manufacturing the product. Okay, and you can save the time. Okay, you can reduce the time by using the tools, different tools. Then increasing customer awareness about quality. So this is very important. Quality, that is your tolerance. Quality is nothing but quality of the product, and next is quality of the tolerance. Whatever the tolerance, okay, which will be given by the customers. Okay, you should reach the tolerance. So this is why. So for all these reasons, okay, we should use the CAD tools. Either you can go for CAD, or you can go for manufacturing tools, or you should go for AI tools, or you should go for management tools. So all these tools, whatever I have explained you now here. So all these tools you require in a company. Okay, I'm telling you in a manufacturing company, manufacturing of the products company. Okay, now it's not about sales. Okay, if you go for sales, okay, you want AI, so there will be no manufacturing, right? So right, students, can you hear me?
Yes, sir. You're audible, sir.
Okay, good. So I'm explaining you regarding to the manufacturing plant. So if a company has manufacturing of the products, you want all these tools. But when you go for only service based companies, so for service based, you do not want like production tools are not required. Only they will be doing the service. Okay. So next, quality is not required because there is no production of the products. You want AI tools, artificial intelligence tools, and you want the design tools. Only these two tools are enough for service-based companies. Okay, like they'll be solving the problem, and they'll be giving the results for other companies. Okay, that's for service. But once you go for production-based companies, you'll be having all these things, all these softwares. Okay, so I'm telling you, kindly go to some production of the products. So once you enter into the company in design tools, okay, then you can enhance your what you can say the software skills, and you can jump into AI tools, or okay, in AI tools you can go for like Python, Michelin, whatever you want. But initially you can join to design tools. Okay, then you can try to learn some softwares regarding to the requirements of the company. Then you can jump to the AI tools, or you can go for production also, whatever you want. Okay, you can jump. If you go for production plant or production industry, okay, then it will be easy for you to jump anywhere. Okay, from design to AI tools, or design to production, design to manufacturing, or design to quality, design to management. So all the tools are required in the manufacturing plant. Then development in computers. So availability of computers with enhanced memory and faster computing speed at affordable prices. So why you want this? Can anyone tell me? Faster computing speed. Why you want this faster computing speed?
So then you can perform the activities that are much faster. It's assuming like the software, sir. Like
Mm.
for FEM software, if you do it on an i3 processor, it takes a lot of time for it to like test it out and give the results. But whereas if you do the same process in i7, it gives you at much faster rate.
Okay. Good. Okay. Good searching. So this is very important. Okay. If you go for the company, okay, the what you can say the ROM. Okay. See, the ROM which should be provided for the system and graphics card. Okay, it should be having high. Okay, like it like 64 GB, 64 GB or 21 to 1 or 128 GB. So our system maximum will be using 8 GB RAM, 8 GB RAM, right? So in this, if you solve the non-linear problems, like if you want to solve the plasticity problems, so which is entering beyond your elastic limit. Okay, for solving those problems, for a simple problem, if you take a simple problem if you take a simple problem like bars or trusses, or if you go for the beams, okay, it will take around 2 to 3 hours time. Okay, you can solve. I will give you one problem for you if you want. You install ANSYS Workbench, and if you want to solve a plasticity problem, this nonlinear problem, it will take at least 3 hours time. Assume only for simple problem, it will take 3 hours time for 8 GB. If you have 8 GB RAM system, okay. If you want to solve for steam turbine blades or wind turbine or IC engines, so it will take at least 2 days or 3 days time. In your system, I'm telling you, in your system, it requires 2 to 3 days time. Okay, so for solving fast, you want more what you can say uh, more it should have more capacity. The computer should be having more capacity ROMs. So that is what they're telling. So in computers, always they should that computer should perform. Okay, it's the speed should be very good. So that for non if you want to do nonlinear analysis for complex problems, it should solve at least for 3 hours or 4 hours. Okay, my friend is working in Siemens. Okay, he has told me that to solve the wind turbine problem, okay, regarding to nonlinear analysis, it will take around 26 hours, 26 to 28 hours in his company. Okay, then that computer has around 128 GB RAM. Assume. So so for solving a complex problems, so it will be very, very difficult in our systems. If you take normal systems, okay, you should put for around 10 days or 20 days to solve one problem. I think everyone is understanding, right?
Yes, sir.
So you cannot say in your systems you cannot solve a simple problem for non-linear analysis. Okay, then if you want to solve, you should wait for 3 hours or 4 hours or 5 hours, because meshing will take more time. Meshing means that is dividing into number of parts, right? If you give a shape, sorry, if you give a proper structure to cut into number of pieces, that's called elements. It will take around 3 hours uh, to mesh the product. To solve again, it will take more hours. So I'm telling you, in a simple system, in your system, 4 GB RAM, 8 GB RAM, 16 GB, sir, 16 GB RAM. So okay, for those systems, okay, you cannot solve the problem very easily. So you want high flexible computers, so it can solve very easily within less time. Okay, then development of graphics means obsession with powerful graphic facilities. You want to know that you want the graphics card. Okay, without graphics card, okay, it will be very difficult to solve the problems. Then development of interactive graphics and analysis softwares. So I told you, analysis software is nothing but your ANSYS or Abacus, Naston, Pattern, and if you want to make a design, then you want CATIA, ProE. So all these things are softwares. You want the interactive graphics card, and if you have the softwares, then easily you can then easily we can generate the 3D drawings or 3D model, and you can do the analysis in the software. I think everyone has understood, right? See,
Yes, sir.
nowadays the computers are very important. Without computers, in mechanical field also, it is very difficult to sustain in the industry. So you want what you can say, high powerful computers to solve the complex problems. Okay. Then computer design. So I think everyone has know, right? The use of computer systems to assist in creation, modification, analysis, and optimization of a design. Right? So these things to do analysis, to do modifications, to do the optimization. So I told you, in HyperMesh you have you can do the optimization process. I told you, right? OptiStruct. So hyper OptiStruct. If you go for HyperMesh, there's a in that you have OptiStruct. So OptiStruct is used for optimization of the design. I told you this, right, in the previous class. I think in the second module or first module I told all these things, right, Sachin?
So yes, I think there was like you gave an example of like a machine or something like a drawing, and
Mm.
it they shows like there's like less stress concentration, so you can remove that material. It's unwanted
Yes, yes.
material.
So this is done by OptiStruct, okay, in HyperMesh. So you can whatever you want, you can do in software. You can remove the excess material. Okay, you can remodify the design. Okay, you can create the model. You can create the 3D model. Okay, if you have the conceptual design, you can easily create the model. You can modify the model, or you can do the analysis for the product or of the design. Then you can go for optimization. Okay, then computer assistance, while the designers convert his or ideas and knowledge into a mathematical and graphical model representation in a computer. So if you have a conceptual design, easily you can convert into 3D drawings. Then computer manufacturing. So example I told you, right? So whatever I told you, I think they'll write in the form of words. So use of computer systems to plan, manage, and control the operations of a manufacturing plant through either direct or indirect computer interface with plant's production resources. So I told you. So if you have the software, okay, like Fanuc, if you go for CNC machine, if you have Fanuc, and if you go for rapid prototyping, I think in our part we have 3D printing, right?
Yes, sir.
So in 3D printing also, the 3D printing software will be installed in the system. Okay, and we will see. First we will give the design part. Okay, whichever part you want, we will give the design. First we will see in software whether it can generate or not. Then if it is okay, then only we'll go for actual manufacture of the product by 3D printing process. So if you go for rapid prototype, there is 3D printing for polymers, 3D printing for metals. Okay, right now metals also we can do. Okay, and that is rapid prototyping, that is 3D printing. So CNC machine, if you go for CNC machine, that is, we can see the manufacturing of the product by virtually, okay, by using some softwares like Fanuc. Okay, we will write this, we'll write the G codes and M codes, and we will try to analyze, okay, what is happening virtually. Then if it is okay for us, then we will go for manufacturing of the product. Similar, okay. So you will use the computers initially to plan, to manage, and control. So control is nothing but to control of the speed. It may be speed of the spindle, it may be speed of the, what you can say, cutting, means cutting speed. Okay, so we can control all these things. And if you go for velocity, to velocity of the nozzle, if you go for 3D printing, so what should be the velocity of the nozzle? Okay, what should be the pressure? Okay, all these things are, it comes under the control. So how much we should give the values to finish our task. So everything will analyze in the computers, in the softwares. Then we will input all these inputs from virtual to the real life manufacturing. Okay, the computer monitoring and control. So in this, we will use the CNC machine and rapid prototyping, your 3D printing. So these are the best examples right now in 2020 era. So these are the CNC machines. You want CNC machines like milling machines, CNC milling, CNC turning machines, and you want rapid prototyping process. Okay, all these things are 3D printing are very important. Why? To complete the task or to complete the product within less time. For that purpose, we want all these machines. Then manufacturing support applications, use of computers in process planning, scheduling, then shop floor control, work study, tool design, quality control. So we can control all these things. Okay, like work study. Work study means, okay, to complete the one product. So how much time is required? So how much raw materials are required? So all this comes under the work study. Okay, to complete the task or to complete the one product. So how much time is required in one machine? If example, if to complete the product, okay, to one product, if you require 10 machines, so for first mission, so how much time is required? For second mission, how much time is required? For third mission, how much time is required? Then how much raw materials will be wasted in first mission? How much raw materials will be wasted in second mission? So this is called work study. Okay, so you can schedule the plan. So in how much time you can complete the task. Okay, then process planning. You can do all these things. Okay, tool design. So tool design is nothing but the design of your tools. Okay, to complete the product. Then quality control, how you can control the quality of the product. So everything, okay, we can analyze in the virtual first, then we can implement all those inputs into real manufacturing, and we can complete the task. Okay, I think from this I'll take Monday. It's already 12:10 students. Okay, from this I will take from Monday, let us CAD cam automation. Okay, from this I should finish CAD cam. Then I will go for this. This is very important sketch. Okay, these two sketch. Then I will go for next. So anyone has any doubt in today's class? See,
No,
mainly
sir.
so today's class I told you about the main thing is the software, right, in the industry. So kindly look into this, your AI tools. It's very, very important. So you have around still you have 2 to 3 months time or 2 months time. At least learn some Python programming regarding to your mechanical problems, like your mechanics of material problems, or you can go to you can learn the kinetics of machine. Okay, for finding the velocity, acceleration for a particular four-bar mechanisms. Okay, all these things you can learn in Python easily. That is, see, it's very easy. So learn this software and kindly after completing the projects, okay, then you should write. Then you should all these things you should update. Okay, in your resume. Kindly do this. Okay, whatever you learn, kindly update those things in your resume so that it will be helpful. Okay, to you, so that the company will call you. So if you write Python, it's enough, but you should know to solve the problems. At least you should know the simpler problems to solve. So you if write Python, write some 5 to 6 problems. Whatever you solve, you can solve. You can solve. If you solve auto footage process, you write down auto footage process. AUTOFRETTAGE auto footage process. If you solve auto footage process problem by using Python, you solve only 1 or 2 problems. It's enough. You can you 90% you'll get the interview. You write down 1, 2, 3, 4 problems, at least 4 problems, simple problems which you can solve by Python, by using Python. So 90% you will get the what you can say interview, because you are fresher, right? You're finishing the engineering now, so you'll get the interview. Okay, easily you can get the interview.